Hey everyone, let's talk about something we all dread, the power outage. That moment when everything just stops. But what if that whole concept could become a thing of the past? Seriously, today we're diving into a new kind of engine that promises to do just that, and it could totally reshape how we think about our energy. I know, a world without power outages? It sounds like science fiction. But the tech we're digging into today, it really does lay out a roadmap for a power grid that's always on. And look, we're not just talking about a slightly better backup generator here. This is a whole new ballgame, a fundamental shift in how we actually make and move electricity. So let's start with the problem, right? When the lights go out, we all know that feeling of frustration, of being completely cut off. And honestly, our current backup solutions, they're often clunky, unreliable, kind of like a relic from another time. We really need a solution built for today. Okay, so this really breaks it down. On one side, you've got the old guard, traditional diesel generators. They're slow to kick in, they guzzle fuel, need tons of maintenance, it's a headache. But then you look at this new approach. We're talking instant power, crazy high efficiency, and a lifespan measured in decades. It's not even a fair fight. This is a total game changer. All right, so what exactly is this radically efficient engine? It's called a free piston Stirling engine, or let's just call it FPSE. Now, a Stirling engine itself is super cool. It runs by heating and cooling a gas inside a sealed chamber to push a piston. But the free piston part is the magic here. It means there are barely any parts actually touching or rubbing against each other. And that is huge. When you see the numbers, you'll get it. This isn't a small step up, it's a massive leap. Let's put this into perspective with an efficiency showdown. Your best-in-class diesel generator, it's lucky to hit 40 or 50% efficiency. That means half the fuel you put in is just wasted as heat. It's just gone. The FPSC, though, it's sitting at over 74% efficiency. Think about that. It needs almost 40% less fuel to do the same job. That's a mind-blowing difference. That means huge savings and a much smaller environmental footprint. And yeah, that number, 74.14% net thermal efficiency, this isn't some engineer's dream on a whiteboard. This is real, it's proven, and what it means is simple. Less money spent on fuel, a cleaner process, and a much, much more sustainable way to get our power. But, okay, being efficient is one thing. How long does it last? This is where it gets even crazier. A typical diesel generator needs major work every few years and is basically on its last legs by year 10. The FSPE, it's designed for over 100,000 hours of continuous operation. That's more than 11 years without stopping. It's just built on a whole different level for endurance. So what's the secret sauce? How does it last so long? Well, it goes back to that non-contact, bearing-free design we mentioned. Think about it. If parts aren't grinding against each other, there's dramatically less friction, less wear and tear, and way fewer things that can break. It's an incredibly elegant solution that just sidesteps the things that cause traditional engines to fail. Okay, so it's super efficient and it lasts forever, but how does it deliver power instantly when you need it? That's the next piece of the puzzle. The engine doesn't work alone. It has a partner, a secret weapon that creates what's called the always-ready power loop. This is where it gets really cool. The whole system is actually a team of 3 working in perfect harmony. You have the FPSE generator itself, that's the muscle. Then you have the Unipower core, which is a specialized energy storage unit. And finally, a central inverter to manage everything. These 3 parts together are what make the magic happen. So check this out. This is the self-sustaining loop that makes it all work. The FSPE generates its 60 kilowatts of power, but it siphons off just a tiny fraction of that, only 2 kilowatts, and sends it to the Unipower core. That core then sends that same 2 kilowatts right back to the engine's heater. It's like it's sipping its own energy to keep itself warm and at the perfect operating temperature, 24/7. It's not off, it's not cold, it's idling, always ready to go from 0 to full power in an instant. This incredible ability has a technical name, continuous black start. And all that really means is it can go from its ready state to full power in milliseconds, completely on its own, without any help from the main grid. It's the ultimate safety net. Grid goes down, doesn't matter, you've got power. This is the very definition of energy independence. Okay, this tech is amazing, but what does it actually do for us? How does it impact a real community? Well, this is where we zoom out from the engine and look at the bigger picture. We're talking about powering a truly resilient community, creating local independent power grids, or microgrids, that can keep the lights on for entire neighborhoods, no matter what. Get this. Just one of these 60 kilowatt units can reliably power about 25 average homes. Think about that. One machine, keeping the lights, the internet, and the refrigerators on for a whole chunk of a neighborhood. That is a powerful tool for building communities that can take care of themselves. And remember that Unipower core? It's really the unsung hero here, playing two crucial roles at once. First, it acts like a shock absorber for the local grid, instantly handling any sudden spikes in demand to keep things stable. And second, it's what provides that little trickle of power, that 2 kilowatts, to keep the FPSE engine itself in that always-ready state. It's the ultimate multitasker. But what about the cost? I mean, this has to be expensive, right? Well, let's look at the 20-year total cost of ownership. With a traditional diesel system, you're looking at multiple major overhauls, constant fuel costs, and a lot of downtime. With the FPSE Microgrid, 0 major overhauls, massive fuel savings, minimal downtime. Over the long haul, we're talking about millions in savings. It's not just the smarter choice for reliability, it's the smarter financial choice, period. So let's zoom out one last time. When you put all these pieces together, what does the future of the grid actually look like with this kind of technology? Because this is about more than just a better engine. It's a whole new philosophy for how we get our power. The beauty of this system is that it's completely scalable and redundant. You can start small and add more generator units as your community grows. That's staged investment. If a unit needs maintenance, you can hot swap it without shutting anything down. And, most importantly, it's fault tolerant. If one unit goes down, the others instantly pick up the slack. There's no single point of failure that can cause a cascading blackout. It's just a smarter, more robust way to build. And that's really the key takeaway here. This isn't just a better generator, it's a new blueprint for local energy independence. It's about shifting power, literally, away from a centralized, fragile system and putting it back into the hands of communities. Which brings us back to our big question at the start. Is this the end of the blackouts? I mean, maybe not everywhere, overnight, but for the first time, it feels like a real possibility. A future without power outages isn't just a dream anymore, it's an engineering reality. Thanks so much for joining me for this explainer.